Alright, so let's get started with just going through the slides to review what we learned from the last video. So we can create a if statement of the format if test, and then it has a bunch of statements. So their example is that you can input their GPA, and if the GPA is greater than or equal to 2.0, they accept your application. So flow chart. If the test is true, execute your statements. Then execute the statements that come after the if. Otherwise, just skip straight to the statements that come after. The if-else block basically gives us a decision. If the test is true, do one thing. If it isn't true, do something else. So here, we've just modified that where basically, if your GPA is greater than a 2.0, welcome to Mars University. Else, your application is denied, right? So yes, if the test is true, we execute the if statement. If it's false, we execute the stuff in the else statement. And then we go on to the stuff after it. So, and this is just simply showing that we are using the same statements that I've already gone over. You can pause and review here if you need to, or go over the slides on your own. They're all uploaded onto Canvas. So here's an interesting common thing that happens. So scanner.console is equal to a new scanner system.in. System.print, what percentage did you earn? So here we take in a number, like from 0 to 100, so whatever your score is in like a class, for example. And if you put in, say, and the intention here is that basically if you put in something 90 or above, you get an A, 80 or above, you get a B. But that's not how it's written. These statements, remember, your computer is an evil genie. It will do exactly what you say. So let's say I put in 70. Okay? So, is 70 greater than a 90? No, it's not, so we skip it. Is 70 greater than 80? Or equal to 80? No, it's not. We'll skip it. Is 70 greater than or equal to 70? Yes, it is. We print out, you got a C. Then we go on to the next one. If percent greater than or equal to 60, well, 70 is greater than or equal to 60. So we got a D as well. So we got both a C and a D. Awesome. That's sure to help our GPA. If percent is, then we don't do the if 70 is less than 60, well, it's not, so we don't print out that last statement. Right? So flowchart here is test 1 true. If it is, we do statement 1, then we continue on to the next test, and then the next test, and then the next test. So what we need here is to use ifs and elses together. Right? And you can imagine that basically if we could do if percent is greater than or equal to 90, we could do one statement and then put all the rest of this in an else. And then we could do an if statement and then all the rest of these in an else. And so on and so forth. And it's kind of like a nested doll thing, but that gets ugly. So instead, what we can use is else if statements. So the idea here is that we can have many independent tests. Right? So, these are interdependent tests. So all these tests were independent of one another, right? It didn't matter what the result was for all these tests over here, right? They all executed independently. Here, these are interdependent. It depends on what happens with the first one. So here, if this is true, we execute this. Otherwise, we test this one. And if that one's true, we execute this, and then we're done. Otherwise, if neither of these are true, we go to the last one. So for example, suppose we have some int x over here. If x is greater than 0, we'll print out positive. If x is less than 0, we'll print out negative. Otherwise, we'll print out 0. So let's say x is negative 2. Is negative 2 greater than 0? No. Is negative 2 less than 0? Yes, so we'll print out negative. And then we just skip the last line. So right, is test 1 true? If so, we do the first thing. Otherwise, we check test 2. Otherwise, we go on. And we can make as many of these as we need to. So the rule being is if it ends with an else, exactly one pass must be taken. Right? Otherwise, if you've got an if followed by an if, you can do any of these or none of these or all of these. Right? So if place is equal to 0, so your first place, gold medal. Else if you're in second place, silver medal. Else if you're in third place, bronze medal. So the else if basically means that only one of these things can be true. Right? So, and I really like the slides, which is why I pulled them up. Normally I don't do these. I don't like slides too much, but these I like because it shows exactly one path. These are mutually exclusive. If this is true, else if this is true, else this is true. Here, note these could be 0 or 1 path. If this is true, do this. Else if this is true, do this. Else if this is true, do this. And notice there's not an else, right? There's an else over here. There's an else over here. These are mutually exclusive statements, right? But in this case, where exactly one of these will execute, only, exactly 1 or exactly 0 will execute here, right? Because it could be that all these things are false, so nothing executes, right? But only one of these will execute. Now, in this one, where we have a bunch of ifs, right, and that's all the way back to here, if I put in 100, all of these 4 will execute, and this one won't, right? So here's a good, nice test for you to figure out what you want, and you can come back here when you feel more comfortable. But which one should you use? Should you use ifs, a bunch of ifs, so completely independent tests, nested if-else, right? Or an if-else-if, right? So whether a user is lower, middle, or upper class based on income, right? That's got to be a mutually exclusive choice. If, else, if, else. Right? Whether you make Dean's List or Honor Roll. Dean's List or Honor Roll, you can make either of those or none of those. Right? So see how that needs basically how here, this first one, you can do, well, it's got to be one of these 3. Well, you can make Dean's List, or you can make Honor Roll, or you could be like me and make neither of those. So whether a number is divisible by 2, 3, and or 5, it's possible for none of those to be true. It's possible for all of those to be true. So that seems like case 1. Computing, and now back to our original one, computing A, B, C, D, or F based on your percentage, well, only one of those should be true. You should only get 1 grade. So if, else if, else if, else if, else. So there's some example programs for you to check out here. Again, you can go and check those out. But let's go ahead and rewrite that bit of code they had over there. Public static string. Well, let's go and do void print grade. Int percent all right. Is he having a good time over there? Doesn't sound like it. All right, so here we want to rewrite this statement where basically we want to tell whether we got an A, a B, a C, a D, or an F. So we know that if our percent is greater than or equal to a 90, right, that's an A. So system.out.println A, right? Else, right? Well, what we had over here was just a bunch of these nested together, which was, and I can copy paste them pretty quickly. So 80, 70, 60, E, C, D, right? Percent 60 or less, you got an F. So here we run our code again. /*/ print grade 100. So let's run this. We run this, it will print out A, B, C, and D with print grade 100 because all these are independent of one another, right? Right? This test is independent of this test. They don't rely on each other. We need else ifs to make them independent. So else, right? So here, if it's great, so 100 is greater than 90, so we're going to get an A. Otherwise, if it's if we didn't get an A, but our grade is above an 80, it's going to be B. So logically, we can think it's between an 80 or an 89. Now, there was another way to solve this, which is to actually, use the ranges that some ranges over here. We could say if the percent of the grade is, if we're greater than 80 and percent is less than or equal to 90. But that's more work. And again, it doesn't show that we really would like this so that these are completely independent choices. And we haven't learned and yet, so we'll get into that. And here, we'll just remove this condition entirely and replace it with an else, because if you don't have an A, a B, a C, or a D, you're going to get an F. So now, when we run it, these are all independent conditions. We can only choose one of them. So A, we do 72. This will give us a C. All right. So now let's go ahead. So I think that's a good logical place to stop this video. So we'll continue on with logical operators in the next video.